Let's talk about the angle-angle similarity postulate, which you first see in Lesson 18. Please make sure to actually go through Lesson 18 and read through the information on angle-angle similarity before viewing this video. This video is meant to be supplementary, meaning that I'm adding on to what you learned in Lesson 18 and maybe clarifying some stuff, but I won't be going into full detail. For example, in Lesson 18, you work out an informal proof, go over some examples. That is stuff I will not be doing here. So again, check out Lesson 18 and then use this video to supplement. So the angle-angle similarity postulate says that if two angles in one triangle are similar to the corresponding angles in another triangle, then the triangles are similar. Again, if two angles in one triangle are similar to the corresponding angles in another triangle, then the triangles are similar. Now, a lot of verbiage here, but when you break it down, it's actually pretty straightforward. Part of understanding this postulate is making sure we understand all of the vocabulary in it. So, if two angles in one triangle are similar, meaning they have the same shape, but not necessarily the same size. Okay, so again, similar angles have the same shape, not necessarily the same size. To the corresponding angles, which are angles in the same relative position in two different polygons. For example, I can pretty easily see just by looking at these shapes that angle A corresponds to angle K. I can see that B corresponds to L. I can see that C corresponds to M. Again, these angles are in the same relative position. They are corresponding angles. What about triangles are similar? What are similar triangles? These are two triangles in which corresponding angles are congruent and corresponding side lengths are proportional. Okay, so think about similar triangles as just an expansion on our idea of similarity. So if I have two similar triangles, again, all of my corresponding angles are congruent, and my corresponding side lengths are proportional but not necessarily equal. And this goes back to our idea of similarity, which is having the same shape but not the same size. So two things that are similar will have the same shape but not the same size. Two triangles that are similar will have all of the same angles but not necessarily all of the same side lengths. So for our postulate once more, if I've got two angles in one triangle that are similar, so for example, if I know that angle A is similar to angle K, and I know that angle B is similar to angle L, then I could say that my two triangles are similar. Okay, so notice that I picked out two angles in one triangle, my triangle ABC, and I'm talking about their similarity with their corresponding angles, right? A corresponds to K, B corresponds to L, C corresponds to M. So if I've got my two sets of corresponding angles and they are similar, then my triangles are similar. So in this example, let's say that you were told that angle A is congruent to angle K. So angle A is congruent to angle K, and angle B is congruent to angle L. Well, that's exactly what the postulate is saying. It's saying is if you have that exact criteria and you know nothing else, then you can claim that your two triangles are similar. Again, you've established that one angle, or two sets, I should say, two sets of corresponding angles are similar, then the triangles are similar. Okay? Now, you may be wondering about the wording here because the postulate talks about similarity, but in my example, I didn't say similar, I said congruent. So how come knowing congruence meant I could still talk about the similarity postulate? Well, the definition of congruence, we'll get to this note in a second, but here's my definition of congruence: having the same size and shape. Okay, so this kind of exceeds similarity, and here's what I mean. If you know that things are congruent, then they are definitely similar. If you know that things are congruent, then they are definitely similar. Okay? Because again, similarity just talks about the same shape. Congruence is the same shape and the same size. Okay? If you have congruence, you know you have similarity, but not the other way around. So, If angle A is congruent to angle K, then that means angle A is similar to angle K. If angle B is congruent to angle L, then that means angle B is similar to angle L. Because I have two of those angle similarities established between two sets of corresponding angles, I know that my triangles are similar. So notice here that only two pairs of corresponding angles are shown as congruent and none of the sides are shown as proportional. So we don't necessarily know anything about the sides. Again, if this is the only information you had about your two sets of corresponding angles, that's enough to prove similar triangles. Now these two angles we are using because that's the information that we were given. It doesn't matter which two angles you're talking about in your triangle as long as they are your corresponding ones. So for example, if we knew information about C and M, we could have used it. This diagram didn't give it to us. However, by the third angle theorem, we know that if two angles in one triangle are congruent to two angles in another, so in other words, this exact line right here, because of that information, we actually can also establish that angle C is congruent to angle M. And think about why this makes sense, right? We know that the interior angles of triangles must add to a certain number, right, to 180 degrees. So it kind of makes sense that if you know that 2 out of the 3 are congruent, that the third ones must be congruent as well. I won't go too much into this theorem, but again, if you have this postulate satisfied, then you can also claim that your third angle, your third set of corresponding angles are congruent, and this makes sense with the definition of similar triangles, right? Because in similar triangles, we're talking about two triangles in which all sets of our corresponding angles are congruent, okay? Main point of focus here. Again, if two angles in one triangle are similar to the corresponding angles in another triangle, then they are similar, but you have to have that information, regardless of what else you know, to prove similarity using this particular postulate. So let's move forward and take a look at an example. And I want to just kind of go over some pitfalls that can happen when we're looking at examples with A A similarity. So let's look at this example. Say you were given this diagram and you were asked whether you could use the angle-angle similarity postulate to establish whether your triangles are similar. And in this case, we'd be talking about triangle ABC and triangle CDE, right? It's triangle ABC and triangle CDE. Now, notice that angles B and D are both right angles. I'm not guessing that, I am told that in the diagram, right? They give me that right angle symbol. Because both of these are right angles, I know that they're both 90 degrees, and I know that they're congruent by the right angle theorem, right? Makes sense. If I've got two right angles, they must be congruent because I know that all right angles measure 90 degrees. Angles of equal measure are congruent. So, since I know B and D are both right angles, I know they are congruent. That's not enough though, right? I need to know that two sets of corresponding angles have congruence. Well, what about these angles here? What about these angles here? These are vertical angles. I don't have much time to get into that. Basically, if I've got two intersecting lines, then any two non-adjacent angles formed by those lines are congruent. In other words, my opposite angles are congruent. So this guy is congruent to that guy, and this guy is congruent to this guy by the vertical angle theorem. Again, it's two intersecting straight lines. Anyway, so now I've established a second pair of corresponding angles that are congruent. I know that B is congruent to D, that's my first set of angles, and I know that this angle, we'll call it ACB, is congruent to ECD. That's my second set of angles. So I've got two angles in one triangle, so two angles in one triangle, and I know that they are congruent or similar to their corresponding angles in the other triangle, which means that yes, I do have enough information to say that these triangles are congruent. Notice that it wasn't based on what I knew about this similarity postulate alone. I also had to have knowledge of the right angle theorem. I also had to have knowledge of the vertical angle theorem. Not all of your examples will require that, right? In the last picture we looked at, we didn't really need to know anything about theorems because the diagram was marked out for us. But here you did need to know that. Point being, be on the lookout for how you can apply theorems or postulates you've already used. Because again, had we just looked at this diagram, it didn't have any congruence marks on it at all. So just a quick cursory glance at this, you might have thought that there wasn't enough information because you didn't see any congruence marks. So we did have to apply some theorems to get to that point where we could apply our angle-angle similarity postulate. Okay, so that's one example. Again, you have to establish two sets of corresponding congruent or similar angles. Now let's look at another example. This is very similar to the last, but notice last time this was put as a right angle and this time it is not. So I don't know anything necessarily about that angle. Okay, yeah, it looks like a right angle, but unless they tell me, I can't really assume it. So say you were given this diagram now and you were asked, can we use the angle-angle similarity postulate to say that these two triangles are similar? Well, again, I know that angle D is a right angle, but I don't know that angle B is. So I can't establish that those two angles are congruent. I could still make the same claim and say that this angle is congruent to that angle by the vertical angle theorem, right? But that's only one set of angles. And then again, if I knew anything about angle A and angle E, if I knew that they were congruent or similar, then I could make a claim, but again, I don't know anything. So since I can't establish any sort of similarity or congruence for my corresponding angles A and E, and I can't do it for my corresponding angles D and B, then that means that there is not enough information here. So it doesn't necessarily mean that the triangles are not similar, it just means I don't know enough information to know if my triangle ABC is similar to triangle EDC. So again, point being, don't assume unless it tells, like, had they told us this was a right angle, that would have been fine, but they didn't tell us that, and we're not allowed to assume it unless it is actually marked. And the vertical angle theorem doesn't really help us as far as establishing that sort of congruence either. So again, don't let a diagram like this fool you. Although it's very likely that angle B is a right angle, it wasn't told to us, therefore we cannot assume it unless you have some sort of other information to leverage. Okay, so again, this is not enough information. One more time, the angle-angle similarity postulate tells us that if two angles in one triangle are similar to their corresponding angles in another triangle, then the triangles are similar.